Good morning, students. So we have seen what is SSL connection and SSL session in the last video. Now we'll see what are the different services provided by the SSL record protocol. So confidentiality and the message integrity, these are the two services provided by this TLS. So confidentiality, as we know, the data will not be disclosed other than the sender and receiver of the particular message. Okay, so for that, for achieving the confidentiality, we are using the symmetric encryption with the shared secret key, okay, which is defined by the handshake protocol as a technique for achieving the confidentiality. And the algorithms are what? AES, IDEA, RC240, DS40, DS, 3DS, Fortress, RC40. So these are the different options available for us for symmetric encryption. After that encryption, what happens? The message is compressed. Okay, message is compressed before encryption, and it is not compulsory, it is optional. Okay, so why we are compressing the message? Most of the time the objective is to reduce the bandwidth requirement. Okay, the next service provided by the SSL record protocol is what? Message integrity. Message integrity is what? The message which is sent by the sender is received as it is by the receiver without any modification. Okay, then that is what your message integrity, and that is message integrity achieved by using the MAC, that is the message authentication code with the shared secret key, okay, which is very similar to HMAC, okay, but with a different padding. So these are what the two different services, confidentiality and message integrity, provided by this layer. Now let us see the next part of this SSL record protocol operation. Now how SSL apply this particular security approach to the respective data or the message. Now let us see in this particular diagram. Now in this presentation you will see the application data, okay, application data which is coming from the different web applications which are running as a part of the application layer. Now once that data is generated by that particular different application, that data is divided into the multiple fragments. Okay, so entire application data which is generated by that particular application is divided into the multiple fragments. Later on these fragments are compressed, but this is not compulsory. If you want to if you want to compress, then you can compress, otherwise you can pass this data as it is for the next step. So the next step is what? The compress, where you can compress the different fragments. Okay, after once it is compressed, you are providing this particular compressed data fragment to the MAC. Okay, so message authentication code is what? Is message authentication code accepts your compressed fragment and creates one MAC, message authentication code, which is appended to that particular compressed fragment. Now in this add MAC step, you will see there are two actually squares. One is the first rectangle, which is what? Which is your actual compressed fragment, and to which we have appended the MAC, which is generated based upon your compressed fragment. Now for the next encryption, we are passing this as it is, means along with the MAC, that compressed fragment is passed for the encryption. So now encryption, as we know, we are using the symmetric encryption technique. Okay, symmetric encryption technique for encrypting the compressed fragment, and we are using, as we know, the shared secret key, okay, which is shared by the handshake protocol. Okay, by using that key we are encrypting the compressed fragment, okay, along with the MAC. Okay, and then we are appending SSL record header. So this is what your SSL record protocol operation, which is basically applicable to the different types of different fragments, okay, of the application data which is generated by the applications. Now next protocol is what? SSL change Cipher specification protocol. SSL change Cipher specification protocol. As we know, while studying the SSL connection and SSL session, there are two terms, pending state and current state. So this is what the shifting of states. So now whenever you want to change the state from pending to current state, okay, at that time it is necessary to update the Cipher suite in use. Okay, and the value of this Cipher suite specification protocol is 1 byte. Okay, so what will happen when the pending state becomes the current state? At that time the value associated with this change by Cipher specification protocol is changes. Okay, hence we are updating the Cipher suite in use from pending to the current state. So while studying that handshake protocol, we come to know that what are these current state means, what is the pending state actually, and then all these points will become clear to you. Okay, so this is what SSL change Cipher specification protocol, which is a 1 byte protocol. Now here is the what SSL Alert Protocol. Now we have seen what the operations of the SSL record protocol. We are performing the number of operations, and we are adding some security SSL information into that particular compressed or the encrypted fragment. So most of the time there are certain issues or the errors which are related to that particular operations. So to inform that error or that particular warning, SSL protocol is used. So the SSL protocol is basically conveys the SSL related alerts to the peer entity. So if there is a problem while performing any of the SSL operation, then that particular warning message or the any other message is conveyed to that particular peer entity. So based upon that, we just try to understand what is the severity of that particular alert. Okay, so again there are two types, warning and the fatal. Okay, fatal means what? It is an unexpected specific alert. Okay, there are two types of alert. One is the fatal errors and another one is the warning. Okay, so fatal is what? You cannot avoid that. Okay, you cannot avoid that. Without without removing this, you cannot go further. So fatal alerts are examples: unexpected message, bad record MAC, decompression failure, handshake failure, illegal parameters. Okay, so these are what? These are the different types of fatal alerts. Okay, so without overcoming this, we cannot go next. Others are the warning. Okay, if you get some warning that is close notify, no certificate, bad certificate, unsupported certificate, certificate revoked, certificate expired, certificate unknown, even in this case you can continue that operation also. It depends upon you. If you are ready to face any of the security related issue in the future, then you are allowed to go further in that particular scenario. So that is what the warning messages. Okay. So compress and encrypted like all SSL data. So all these messages or the alerts are now compressed and encrypted like all SSL data. Now in this presentation you will see that the alert protocol format, that is 1 byte, label and alert. So label may be what? Fatal, or label may be warning. Okay, so in this case if it is a warning, then it becomes a 1, value is 1, and it becomes a error, then value becomes fatal. And the next part of this 1 byte is what? It is used to represent the actual message, okay, associated with that fatal or the warning. So this is all about your SSL architecture, SSL session, SSL connection, then SSL Alert Protocol, change Cipher specification protocol. Now very important protocol which is remaining, that is the handshake protocol. So we'll see that part in a subsequent session. So meantime, you just go through all these presentations. Please read the PDF which is shared on the Moodle, and if you have any question, please note down that question. So and note down that questions, and you can ask that question